So what's a safety connection? A safety connection is an opportunity for you to learn some cool stuff from some cool peeps, where you are attending from your personal workspace. And it's for us to be able to also exchange some best practices and some ideas. So we'll be hitting you up as well for some of the things you're doing well, and maybe some of the challenges that you are having. Virtually connect with your industry peers and to learn and discover what's of value to you. You know, we may have a conversation about, for instance, explosives, and you go, well, I don't work with those, I work with this. And the goal of this is, I like to say, picking out the nuggets of gold that are most relevant to you. So let's move forward to get to know each other a little bit better. Hi, I'm Tova Larson. I work for Workplace Safety and Prevention Services. I am a health and safety consultant based out of Ottawa. I have been with WSPS for 10 years now, celebrated my 10-year anniversary 2 weeks ago. Super excited. I'm still as excited to be here as I was 10 years ago. I did not start my career as a health and safety professional. I started my career as a laboratory chemist. So I used to work in supramolecular medical nanotech. I am a materials chemist, and I spent the early part of my career developing drug patches with nanotubes. Then I got hurt at work, and I work in health and safety now. That's a little bit about me and my background. And just as a and we might tell some stories as we go. But one also fun fact about me and flammable liquids is that my family home also nearly burned down not once, but twice from flammable and combustible liquid fires. So I have some stories about that, and I have some lessons that we learned from that. That is a little bit about me. As I think I said, I was based in Ottawa, and I'm going to turn it over to Tony, who's going to introduce herself and talk a little bit about the Hygiene campaigns that are ongoing right now with the ministry, which are so important.
Great, thanks, Tova. Good morning, everyone. So glad you can make the session today, and I really hope you can take away some great information to prevent injuries, illnesses, fires, explosions when working with chemicals back in your workplace. I joined WSPS over 25 years ago, now as a health and safety consultant, and I kicked off this career really had a co-op positions in health and safety departments through my co-op at the University of Waterloo. And it really resonated with me that because my father was a welder and I was his sidekick, it would have been just devastating to me if something would have happened to him at work. So just so important. And I'm just so thankful that you all committed to coming to this today and learning and doing the best you can to prevent injuries and illnesses at your workplace. And most recently, 2019, I got my CIH designation. So super happy to now be working with the hygiene team at WSPS. So we do a variety of services. We can do air testing, noise testing, respirator fit testing, program development, all of those great things. If you're needing help with those, please don't hesitate to reach out for us. Here is an updated chart from the WSIB this year regarding the allowed fatalities over the past several years. So this is really, I think, why the effort? Why are we here today? The blue at the bottom is the traumatic fatalities, and the gray is the occupational disease fatalities, and then green is the COVID fatalities. So also, on the Ministry of Labor, Immigration Training and Skills Development website, they also report that occupational diseases are the leading cause of worker deaths. So exposure to hazardous chemical agents in the workplace may result in a worker developing an occupational illness. So identifying, assessing, and controlling these exposures will help you lower any risk of workers developing an occupational disease. So it really was shocking to me when I first saw these statistics from the WSIB, not only the number of fatalities that occur, but also that occupational disease fatalities far outnumber the traumatic incidents. And yes, there are MLITSD occupational hygiene campaigns running again this year. It started last year, but again for this year, it is the same. What they're focusing on is the WHMIS training based on the amended hazardous products regulation. And the second one is worker exposures to chemical agents in the workplace. So the inspectors will be out enforcing Regulation 860 and Regulation 833, really at where any workplace where these regulations apply. So the education and outreach is happening, as well as enforcement. It's just ongoing because it did start last year. So they are continuing with these campaigns this year. So why are they focused on WHMIS right now? So the rationale is the Federal Hazardous Products Regulation, the HPR, requires suppliers of hazardous products to provide safety data sheets, or SDSs, and ensure that the containers of those products are properly labeled. So the HPR was amended back in December of 2022 to include changes in hazard classifications and information elements in the SDS. And then there's a 3-year transition period for suppliers to comply, during which time workplaces will begin to receive updated SDSs and labels for their hazardous products. And the goal here is will require retraining of workers on WHMIS when those new updated SDSs are received, to ensure that workers really understand the changes that have been made in the SDS and labels, and to really reinforce and ensure everyone knows how to work safely with the hazardous materials that they're handling in their workplace. So you may be wondering, how do I know if I have an updated SDS that's in compliance? A good tip that I received from the provincial hygienist at the MLITSD is she said, look in section 9 of your SDSs. The ones that have been updated, it is a requirement now to have this additional R, particle characteristics heading in this section, which is highlighted here. So all these sections need to be in the SDS now. Even if the heading doesn't apply to that chemical, the supplier can just write beside it, not applicable. So if an MLITSD inspector is arriving at your workplace and they may be reviewing your safety data sheets, and if they see you do have the updated SDSs, they may be asking, have you done your updated WHMIS training for these chemicals? And again, they want to make sure your workers are understanding the critical information, how to handle chemicals safely. So you want to be prepared, and I'm sure you all will. You'll be ready and show them that you've done it and you have documentation of your training, and ensure you're talking about the details of how to handle those safely. So just briefly, some of the things they'll be looking for, the MLITSD hygienist. They're again out there proactive inspections to ensure compliance with both the WHMIS regulation and Regulation 833. So more specifically, again, the MLITSD hygienist will determine if retraining on WHMIS is required, depending on whether the hazardous products have the updated labels and SDSs that are now compliant with the hazardous products regulation. And they're also there to determine if people are potentially being overexposed to hazardous chemicals, and that they may require additional air sampling of your workers that could be exposed to these hazardous chemicals to ensure that people are not being overexposed. So that's like measuring the actual air, the concentration that the workers would be potentially breathing in during their day, and you compare those to the occupational exposure limits that are outlined in Regulation 833. And we have a whole other safety connection dedicated to air assessments that has been recorded on our website as well, that talks a lot about that in detail. So again, together, we all can really make a difference and ensure that our workers are not being overexposed to the hazardous chemicals and that they know how to handle and work with these chemicals safely to prevent any injuries or illnesses developing. And now I'll pass it back to Tova to proceed with our flammable and combustible.
Awesome. Thanks, Tony. All right, let's go ahead and talk about what we're going to be covering here in the program. We are going to be talking about understanding fire and recognizing risk. We're going to be moving on to talk about assessing flammability risks and legislation. Then we're going to be talking through the hierarchy of controls about preventing flammable liquid fires and about emergency response. So first, we're going to start with a quick chat question. What are your greatest challenges, do you think, in appropriately managing your flammable and combustible liquids in the workplace? What do you think your pain points are? Drop that into the chat. I would love to know what you think your biggest challenges are. Storage is coming up as a hot topic. Storage. Disposal, good topic as well. Complete inventory list, absolutely. Storage, lack of understanding, one person being responsible for SPS maintenance. One person ultimately probably should be, so that you don't get a lot of cooks in the kitchen. Interpreting the fire code, hot tip, and there's going to be a lot of fire puns in this, by the way, so if you like puns, we're here for you. If you don't like puns, I just stay here for this. Yeah, that is a hot topic to discuss with an engineer because they're really good at interpreting that. Secondary containment. You're clearly after my own heart, Nicole. Proper use of fire cabinets. Yeah, more of storage and disposal, knowledge and training, disposal, PPE usage, everyone using proper PPE. I mean, PPE also has its own problems because some of that is flammable, and we'll talk a little bit about that. Intrinsically safe items allowed only, absolutely. And I guess getting people to really understand what's intrinsically safe, what's not. Just a quick note about raising the hand. Your mics are muted and your cameras are off, so you will actually have to put the interaction into the chat. Spill response, we're going to talk about that. Transferring alcohol from one container to another. Returning items to storage. Sounds like, yeah, housekeeping and storage is a common human error. It is a real thing. Handling and storage of combustible metal powers, really, really specific. And feel free to hit, and again, if we don't talk enough about metal powders and you want to have a deeper dive conversation with that, feel free to hit me up and I'm happy to book a call with you. Handling and large open paint tanks, PSRs, we're going to talk about PSRs as well. Disposal, outdoor storage, nitrocellulose, that is, yes. Flammable solids are not all that common, like truly like solids that are like, can like, poof. But yes, nitrocellulose is definitely one of them. I'm dying to know, you don't work in archives, do you? Because there's a lot of nitrocellulose in that. Decanting, storage. Oh, fantastic. And Mike already dropped the PSR guideline, item 1, right into the chat. So thanks, Mike. Communication, what to do, what do we have to explain to the employees? Talk about that too. All right, let's move on. Storage, non-combustible spill containment berm for flammable liquids. Yep, definitely challenge. We're not going to get too much into like engineering design or berms in this session. We only do have an hour and a half, so there's a limit to how far we can go with this, but we'll be digging into this. Okay, yeah, cabinets are something we're definitely going to talk about. So let's go ahead and move forward. I'm going to go ahead and take control, and we are going to talk a little bit about a few case studies. So this is a famous case of a worker named Sean Kells who suffered third-degree burns to 95% of his body. Sean was only 19 years old when he died, and it was his third day on the job. His father ended up becoming a passionate advocate for health and safety. And, you know, when we look at this incident, it was an automotive after-sales service company. This was in 1994. And one of the reasons we're going to go through these case studies is lots of people, when I talk to them, have this belief that like flammable and combustible liquid fires and flammable and combustible liquid problems are like a 60s kind of problem. They're like, that's 60s, 70s. If you cannot see the deck, I would suggest leaving the teams and coming back in. That solves that 90% of the time. So try that. Try just like hitting leave and then clicking on the link again. People seem to believe that, all these fire problems were like a 60s, 70s problem, and they are not a problem today. And that is the furthest thing from the truth. When we look at 1994, which again was still 30 years ago. Okay, that feels like 10 years ago for me, but it wasn't. So let's talk about what happened. So the individual was dispensing toluene, a toluene-based product, from an unmarked drum into smaller containers. So it was a dispensing activity with a flammable liquid. And in the incident, it was a static discharge that ignited the flammable vapors. It flashed back into the drum and then caused an explosion that led to fire engulfing the worker and leading to that fatality. And on investigation, some of the contributing factors included the lack of bonding and grounding to dissipate the static energy, no worker training, either any worker awareness at all. Third day on the job, he was hired by like a friend's dad to work at his business. And he did not have any hazard specific training. I would be surprised if he had any WHMIS training either. And he definitely did not have adequate training on dispensing flammable liquids or the practices involved. And there was no information provided to him at all. I mean, the drum was also unlabeled, which was not helping, on the flammability of the product or any sort of safe work practices. And the company was ultimately fined $75,000 and the owner was fined $10,000. Now remember, that's $1994, $1994 penalties. Fast forward to 2011, where Eric Layton was an 18-year-old when he died at his school. He was described by classmates as being popular and caring and an athlete, and he was really close to his little sister. This was at Mother Teresa High School in Ottawa, which is really close to where I grew up. And this was a case where he was making barbecues in class. They were using metal drums to make the barbecues. And the teacher had used they had previously contained peppermint oil. And the teacher had actually used a very small amount of brake cleaner to clean the peppermint oil out of the drum, poured it out, and then capped it. And so the drum, because it was washed out with this engine degreaser flammable solvent, even though there was only a little bit in there, we're talking like maybe a couple tablespoons, the drums were closed, which allowed flammable vapors to accumulate. And then there was hot work involved, where the individual was actually cutting the drum using a grinder. That ignited the flammable atmosphere inside of the drum, again, resulting in an explosion. You'll see the containment definitely features prominently in these cases. And there was no hot work risk assessment. There was no planning of the task. Because the drums had been capped, the vapors were not able to escape from the drum. And because they used a flammable solvent to clean this peppermint oil out, it created this flammable atmosphere inside of the drum. Ultimately, there was one fatality. There were 4 injured students, and the OCSB, the Ottawa Catholic School Board, was fined $275,000. And there were also lawsuits filed by the parents against both the board and the teacher. And we cannot forget about Eastway Tank. And you might think, okay, 1994 was a long time ago, 2011, like we learned stuff about flammable liquids since. This is one of the largest multiple fatality situations. This is only eclipsed in Ottawa workplace fatalities by the Heron Road Bridge disaster. This is number 2. There were 6 fatalities in this, along with 1 injury. This was the Eastway Tank explosion. They were wet testing pumping equipment in a tanker truck. So it was a fuel tanker truck. They typically use combustible diesel to do this. And ultimately, the incident was the result of a gasoline air vapor explosion. And then there was a second larger explosion that collapsed the building and killed 6 people. And I'm a real believer in using people's names. These are not nameless, faceless people. The people that were killed in this were Rick Bastian, Etienne Miabella, Kayla Ferguson, Danny Beal, Russell McClellan, and Matt Kearney. Every one of them with people they love, and these people miss them every single day. And I want you to remember that, because when we think about the impact this has on our staff, we cannot forget that every single time someone comes to work, we owe them a duty of care to ensure that they go back home to their families. So what happened at Eastway? In the investigation, they found that the combustible diesel fuel that was used for the testing had actually at some point along the way become contaminated with flammable gasoline, which was then vaporizing and creating that gasoline air mixture that resulted in that explosion. They also had numerous ignition sources present in that workplace. They did welding, they did a bunch of other hot work, they were doing testing, and they also had a history of fires, both minor fires and smaller explosions that did not seem to catch anyone's attention to change their work practices. So they had what we would consider to be, I mean, I wouldn't even consider a minor fire or a small explosion to be a near miss. I would still consider that to be a major incident. But they did not, in fact, investigate and take corrective actions to prevent this from resulting in a fires are also reportable to the Ministry of Labor, Immigration, Training, and Skills Development. Just a hot mention of that. And all of the fire puns, they're completely intended. All right, so what is the legal end of this? The Eastway pleaded guilty to 2 charges. They were fined $600,000 plus, of course, that 25% victim surcharge. The owner also pleaded guilty to charges as an individual. It was 1 charge, fined $80,000 plus a 25% victim surcharge as the owner and owner, operator, director of that business. The owner is still fighting in court. This is still working its way through the court process. Last I heard, they were having conversations about like disclosure and documents, but 6 people died here. Let's not forget that. Okay, moving on from this, did a coroner's inquest occur from the result of this incident? It's still working its way through the courts, and the coroner's inquest usually happens last. So all of the the Occupational Health and Safety Act fines, any litigation, all of those processes have to be completed before a coroner's inquest may take place. I don't know if a coroner's inquest is going to take place from this. I believe there was a coroner's inquest for the Eric Layton case, and that concluded, I don't think it was actually that long ago. So this is the burden that you're talking about. These can be the results of not using your flammable and combustible liquids in a safe way. Death. I can't sugarcoat it. Could someone please share the reference for a fire needs to be reported? You will find that in section 51 to section 53 of the OHSA. So section 51 is all about critical injuries and fatalities. Section 52 is all about disabling injuries, fires and explosions, as well as there's a list of other types of incidents that need to be reported. So if one of our fantastic folks at WSPS wants to go dig up section 52, feel free to just drop that into the chat. That would be appreciated. And I'm going to move forward. So let's go ahead and take a look at understanding fire and recognizing risk. So ultimately, what is a fire? People think about fires as like that you need to have a flammable liquid plus oxygen plus an ignition source. But one of the things that they forget is you also need to have a spontaneous chemical reaction, or not spontaneous. You have to have a like continuing self-sustaining. That's the word I'm looking for, self-sustaining chemical reaction. Thanks, Mike. All right, so that is ultimately what a fire is. You've got fuel of some kind. You have to have oxygen or an oxidizer. And we're surrounded by oxygen, which is probably not helping much. But you have to have a way for that fire to start, and then you have to have that chemical reaction that is sustaining itself. If any one of these things is missing, you will not have an ongoing fire concern. When you think about a campfire, you have to have all three. And as you're sitting there, you've got your like fuel and you've got your oxygen, which is all around you. And then you've got your little match and you're like trying to blow on your paper or whatever you're trying to get this thing started with. And you're trying and you're trying and you're trying and trying. You have all three of those things, but you're missing the spontaneous part, or the spontaneously continuing, self-sustaining reaction. You're trying to make that happen to get the campfire to go. So that is ultimately what a fire is. So what is an explosion? An explosion is taking the pieces of a fire and sticking them into containment. So once we contain this thing, you have the potential for an explosive energy wave to occur. And in all three of the cases that we talked about, containment was a factor in the level of destruction that they saw. So what happens with this containment is it allows, instead of having, like, again, you've got a campfire, there's no containment, it's burning. You've got like a pot of oil, it's burning, but without the containment, you lack the ability to have that explosive wave. When you start getting into explosive waves, the level of damage and the potential for fatality goes way up. Not to say that there isn't a major potential for fatality with just a fire that's not contained, there certainly is. But once you start getting into explosives, the risk goes way up. And by explosives, I'm not talking about explosives like, here's a stick of dynamite. I'm talking about anything you're sticking into containment. So let's talk a little bit about flammable and combustible. Name me some liquids that you're using. I saw some that dropped in the chat. What are you using? Yes, and there's also section 53. Thanks, Leora. MEK, methyl alpha ketone, of course. If you're wondering what MEK is. Super flammable. Solvents and adhesives, gasoline, probably one of the most common flammable liquids that folks would be using because it's used in so many different ways. Isopropyl alcohol, absolutely, mineral spirits, toluene, xylene. Fun fact about xylene, super stinky. The odor threshold on this is really, really low. The actual occupational exposure limit is much higher than the odor threshold. I learned that through a case that I dealt with in a previous workplace. Breath central gas, Betex brake cleaner, paints and stains, acetone, super flammable, paints, propane, fragrances, SLES, gas, hydrogen. Yeah, so lots of different flammable liquids that are used. So let's take a look at some that I made my list that sometimes we forget about. Aerosols. Little aerosol cans, they're typically filled with flammable liquid. Paints and coatings are pretty common, as you can see from what folks are working with. Turpentines, paint thinners, lots of folks were using toluene, mineral spirits type products. Gasoline and acetone are also really common. Even when we think about acetone, we forget about the nail industry. They're working with that. Solvent degreasers and cleaners often are flammable, and with the Eric Layton case, you'll notice that they used an engine cleaner product that was also flammable. Varsol, yep. Methyl ethyl alkylates. I like the description of that. I'm a chemist, and even I have a list of things that I don't like working with. Methyl ethyl ketone makes my list. Another one, acid cell battery charging stations. So you're dealing with gases, that's flammable. We've got flammable gases that are coming from that. One that's definitely high on my list of things that I don't like working with is methylene chloride. It is flammable, but I also developed a really nasty allergy to it. Now, my hands will swell up and my face will start getting itchy if I use it. So not using that anymore. Gasoline, various machine shop chemicals, WF greasers. Yep, lots of different products. And this is a really good list. It's really a great list that shows what so many of the WSPS member firms are dealing with. There are a couple that we forget are flammable. Beverage alcohol is fantastically flammable. If you've ever tried to make a flambé, you know this instinctively, but at the same time, we forget that beverage alcohol is incredibly flammable, and hand sanitizer is flammable. If you're ever camping and you're looking for something to get your campfire going, and you've got a bottle of hand sanitizer with you, you have accelerant. We also have combustible liquids that still, if we heat them up, still have the potential to produce enough vapor to create a fire if a spark were to occur. And some of the more common ones are cooking oils. We forget those are combustible. Coffee whitener is combustible. A lot of that is pretty oily. Lubricating and cutting oils, diesel. Of course, if you heat it up, you can get it to light on fire. Acetic acid, ethylene glycol, and we also forget about things like wood oils and linseed oil. Oh, lithium-ion batteries are a whole other fire session. And in fact, I believe that we did have a session on that. So if you want to know more about that, yeah, coffee whitener, both the powdered kind. If you and don't try this at home, if you toss a little bit of it up in the air and you can actually get that to burn, it is a flammable, like it's a combustible powder. But we also have, and if you're making coffee whitener, you're now dealing with combustible dust problems, and also the liquid stuff is typically an oil-based. It's not petroleum, like it's a food-grade oil, obviously, but it is definitely flammable. Cellulose powder, also flammable powders. We are focusing here on liquids today, but we could have an entire session on flammable powders. Tony, what do you think about that? Jessica, I think you can hear me. Flammable powders. We should probably do a thing on that. Let's go ahead and talk a little bit more about recognizing some ignition sources. And unfortunately for you, they're literally everywhere. Sparks from tools and motors of all varieties. Vehicles, they've got motors, but they also typically have things like batteries. They've got hot surfaces on them. They might be dealing with fuels. They've got spark plugs. I mean, it has the word spark in it for a reason. Electrical switches, plugs, all those things have potential to create sparks with ignition risk, even just static discharge and those hot surfaces and heating appliances. And we're not just talking heating appliances like 2 feet away from where you're working. You can have heavier than air vapors creep for long distances, all the way back to like your water heater, your printer, what have you, and that ends up creating even at the smallest spark, and you can end up with flashback. One of the real challenges with ignition sources is that they are everywhere. Our world is powered by electricity, and this is also an ignition source. And we carry one. You're carrying an ignition source around in your pocket almost all the time. So that's the real tea on ignition sources. And when we think about controlling fire risks, we also cannot forget, how do you know how far vapors can travel? We'll talk a little bit about vapor density as we get into, but ultimately, how far can they travel? How much vapor have you got? The more vapor you've got, the further it can creep. So, ignition spotlight. We're going to put a particular spotlight on static, because when we look at some of those cases, and the case with Chankel's as a really good example, that was actually a static discharge that resulted in that explosion. Static electricity it ends up in our materials through physical contact and separation of positive and negative electric charges that are formed in the process. You've probably all felt static at some point, probably if you have a sibling. You drop your feet on the carpet and you touch your brother. But what's interesting about static electricity is that in liquids, this often is formed when it is being moved. So it's either filtered, sprayed, pumped, mixed, or it's flowing through pipes. If we are spraying it through something like, when you think about a filter, you've got so much surface area in relation to the liquid that you're having to touch. And every one of these little contacts is potential for static to build up. We are inside of a pipe. You've got, let's say you've got a plastic pipe or a metal pipe. Metal pipes are puntable and groundable, but plastic pipes are not. And it's now flowing. You now have that surface. And what's really challenging about static discharge from a liquid standpoint is that this type of static is not touch brother. This is actually internal static that, if you're dealing with a non-polar, non-conductive flammable liquid, may not actually be discharged even through appropriate bonding and grounding, because the liquid doesn't conduct electricity very well. But it can still build up static charge through our handling practices. So we want to be very careful, especially if you're working with a non-conductive, non-polar liquid, in the ways that you handle these. We want to handle them in a way that minimizes the amount of internal static buildup possible with that liquid. Another real challenge is that many of our liquids come in non-conductive containers, which then don't allow us to even be able to bond or ground the container. We'll talk about bonding and grounding to dissipate any static that may in fact have built up from the container. So big challenges here. Use static tinsel across surface on a paperboard. Yeah, I love that. That's such a good example across the surface of the paperboard on the printing press. That's a great example of a control. You've got this static dissipating system in there, and that's why that's there. Can you measure static buildup? Not really all that effectively, I don't think. We also have Mike, who is an engineer. Mike, feel free to field that one. I don't know of any way to be able to effectively measure, and it's really small electrical charges. We're not talking like car battery levels of electricity, but it is not super easy to measure. Feel free to field that one, and we're going to move on. So I wanted to highlight static because people think about static as just static of container to container. They forget about the static. Yeah, the static can be high voltage, but low. Yeah, absolutely. So when we look at the container, people think about static between containers, but we forget about static inside the liquid most of the time. Another hot topic is hot work. Anytime you have welding, cutting, grinding, brazing, soldering, torching, anything that you're creating heat or spark, you have another one of those flame risks. You've got this ignition source. So we want to be very careful in our workplaces. Most workplaces, if you're doing hot work, especially if it's like not hard work you're doing every single day where you're kind of built around that, often involves getting a hot work permit. These are ultimately any activity that involves either open flames or heat sources, sparks, or flame producing equipment. Super, super dangerous. Yeah, I love these bottles, but so expensive. You know, ultimately the question becomes, what do you want to pay for? Do you want to pay for really good engineering solutions, or do you want to pay for potentially replacing your building and potential staff fatalities? I think the juice is worth the squeeze and paying for the expensive bottle. That's my take on the world. You may have a different take on the world. I am someone who got injured. I crushed my right foot. That's actually how I ended up in safety. I got crushed my right foot working in a welding shop when I was 24 years old. And my injury could have been prevented for $30, which is approximately, at that time, dinner for four, a family of four, at McDonald's. And let me tell you, sitting at home for a year of my foot trying to heal, and every day thinking to myself, was $30 in savings really worth a year of my life? It gets under your skin. So if you are about to cheap out on spending money on a good bottle, because you are thinking to yourself, well, this probably won't happen to us, try explaining that to the family of somebody who died. I know it sounds like a really aggressive stance, but having been that worker, having to explain to me that my injury could have been prevented for a $30 toe cap was absolutely devastating. When using the manufacturer's original small size pump bottle, states grounded bond in the SDS is a still requirement. Are there size and quantity exceptions? There are size and quantity exceptions, especially around non-bondable, non-groundable containers. We'll talk a little bit about containers as well, but plastic and glass are not bondable or groundable. So they actually do have limits, but for class 1 and class 2 liquids in the size of the container, because the intention of that is saying, okay, if you absolutely have to handle this in a non-bondable, non-groundable container, at least we're going to not be doing this with a huge quantity of material. Awesome. Thanks, Mike. Questions about static meters? Fire-related SDS sections. This is another way for us to recognize our hazards. Go and take a look at section 2. Look for words like danger or warning. Danger is worse. Warning is still not awesome. It's still warning. Hazard statements. These hazard statements are coming right out of the GHS software, but if it is flammable or combustible, it's going to be in those hazardous statements, and then there are going to be associated precautionary statements on how to handle the product properly. We also can look for some of our pictograms. Some that I like to look for are the exploding bomb, which if I see that, I may not want to work with it. I don't particularly like working with explosives. The flame symbol is, of course, a classic one, but we cannot forget that oxidizers make fires worse. So if you see the flaming circle, that is also something to pay attention to from a fire standpoint. We also want to take a look at Section 3, composition and ingredient information. You may be working with a product that's sort of like a branded product that's using a trade name, but then you go looking in the ingredients and you're like, oh, this stuff is like 25% toluene, 25% acetone, and 10% alcohol. Like, you know, this is going to be flammable. So go take a look at the composition and ingredients. They also have CAS numbers next to each ingredient. So if you're not sure, you can go put that CAS number into Google and you can actually get information from the National Institutes of Science NIST Chembook, which is a great resource if you're looking for things like the exact, all of those like flammability data points for a particular ingredient. Tip. We also have Section 5 firefighting measures, and this is valuable to go and figure out. Awesome, thanks, Tony. This is also a great opportunity for you to figure out what your extinguishing media should be. Suitable, unsuitable, extinguishing media. You need to have these on hand. If it says you need a special fire extinguisher, get your special fire extinguisher. Obviously, you are not providing PPE for the firefighters, but you should have, and I highly recommend, by the way, that you have a way to access your safety data sheets that are not inside your building. It's some way that you're able to like log in remotely, because if you're standing outside of a burning building and the firefighters just showed up, it's really helpful to be able to tell them what you've got and to say, by the way, we can access our safety data sheets on this phone, what have you, to give you more information about exactly what you're getting into so that they can pick the right bunker gear. We also want to take a look in Section 5 at specific hazards arising from these products. Does this produce hazardous combustion products? Does this, what are some in firefighting measures? They also talk a little bit about like preparing for a fire. If this produces like cyanide gas when you burn it, that's really important to know. Some things do. We also want to look, as Tony was mentioning, at our physical and chemical properties. Go take a look to see if you spot particle characteristics so that you can know if it's an up-to-date safety data sheet. But some of the things we look at on the safety data sheets are flashpoint, upper and lower explosive limits, auto ignition, and vapor pressure and relative density. And we'll talk about those too. In Section 10, is also really valuable to look at incompatible materials. If you're dealing with something that's flammable, oxidizers are very high on that list. Storage and use conditions to avoid. Some things will light on fire if they're exposed to shock or to static. So we want to know how to store these properly, and any hazardous decomposition products, which is different than hazardous products on combustion. This is just so this product is aging. Chemicals do not last forever. And as it's decomposing, is it producing new risks? I used to work in a lab that had picric acid that had been sitting on a shelf for, I don't know, about 50 years. And yeah, it was terrifying. Don't touch the bottle. Don't turn the stopper. Don't do anything with it. And you're a little safer than you were other than touching it, which is probably going to kill you. I would recommend commercial buildings have their fire emergency plan by the front door. Highly recommend. This plan could include notes to firefighters. It could also include a binder with your safety data sheets. Nobody's stopping you from sticking a binder of your safety data sheets there, or even just the flammable ones. I would recommend all of them, but that's another good thought. Thanks, William. Let's talk now about assessing flammability. We're going to go and talk first about Flashpoint. Low numbers are bad. High numbers are safer. This is ultimately the lowest temperature at which a material will form a vapor in the air that will briefly ignite. That's called the flash. And when it's exposed to an ignition source. And this ultimately gives you an indicator of when you're approaching the danger zone. So as you're looking at products, look at the flash point and know that high numbers are often not producing enough vapor for this to be able to happen. Low numbers even just at room temperature, are producing plenty of vapor and have the ability to, in fact, light on fire. So what numbers are we looking for? The magic number is 37.8. Anything with a flash point above that is considered to be above. I don't know which direction you can see me pointing, but I'll grab my little laser pointer. Anything with a flash point that is higher than that is combustible, which means that you have to put a little bit of effort, usually a bit of warmth into it, to get enough vapor off of it to be able to get it to light on fire. Whereas if it has a flash point at or below 37.8, it is flammable, and this is stuff that you need to be very mindful of. Anything above 93.3 is considered to be generally non-combustible material. So look for your flash points, know this magic number. I don't usually remember the 0.8. I usually remember around 37, which conveniently is also around the temperature, the normal working body temperature of a human body, which is approximately, 37.5-ish. So if you're like trying to make links and stick things into the old memory hole in a way that you'll remember it, if it has a flash point that is above body temperature, roughly, that is probably combustible, and if it's below body temperature, it is probably flammable. Auto-ignition is also something that I take a look at, and this is the lowest temperature at which this material will self-ignite without an ignition source present. So if I'm sitting there heating up my light canola oil to cook food on the stove, it is combustible. There's a point at which just being hot will cause this like whoosh. And that did happen to my mother. She was making coleslaw salad dressing. My brother was skipping school, as apparently it was a thing for him. And he actually woke up when the fire alarm went off the smoke detector. And he's like, oh, stupid smoke detector. Opens his eyes, house is full of smoke. And he's like, oh my God, it's on fire. Runs downstairs, and he actually managed to save the house. If he'd been like 3 seconds later, I think our whole kitchen would have gone up in flames. So fire extinguishers, train your children how to use them. Fire extinguishers, have one, and don't stick it under your sink because you're never going to be able to get it in time. Put it on your wall. Let's talk a little bit more about auto ignition. Don't heat things above the auto ignition temperature. I wouldn't even like to be approaching the auto ignition temperature. That just sounds scary. Lower auto ignition temperatures are higher risk. High auto ignition temperatures are lower risk. Let's talk now about vapor. One of the big concepts around vapor is, does it go up or does it go down, or is it fully miscible with air? If you have a vapor density number on your safety data sheet that is greater than 1, it means the vapor is going down. What does that ultimately mean? It means that you need to have a lot of suction power to be able to make those vapors go up and out of your building. You could also potentially have vapor collection that is actually at the lower portion and have ventilation from both up and down. We need to be mindful that if the density is less than 1, it's going up. If it's 1, it's fully miscible with the air. The scary part, as I mentioned, with heavier than air vapors is that they can creep for long distances along the ground, and then they can flash back to their original source. Yeah. That is a good tip. Yeah, we actually had it in just inside the kitchen door, which is right beside, like, it was the door to the hallway. And it was about 10 feet from the stove, which was really convenient because he was able to grab it right at the door because it's the entrance point to the kitchen. But that is front hallway. That is a really good idea. And you can grab it on your way out. A lot of people do store them under their kitchen sink, and like, terrible idea, don't do that. Can I get the picture for combustible and non-combustible? I can send you the information. It's if you want, it's super simple. The images are all copyrighted to Getty, so I'm not able to. Wait a minute, is that one copyrighted to Getty? Let me go look. The little flame. I can send you that with the flames removed, and then yes, then you can have it because those are just arrows, and Getty doesn't have the arrows. So let's talk a little bit more about vapor pressure. When you see higher numbers for vapor pressure, this stuff produces more vapor at room temperature. If it's producing not a lot of vapor, you're not getting as much vapor for it to light on fire. Ultimately, what is fire? fire is burning gases. Like even with a campfire, you're taking that wood, it's now producing, you're heating it, it's producing enough gas, and it's actually the gas that's burning. So yeah, hot topic, turning to vapors. This is also a understanding flammability limits. This is upper and lower. So if you are in the lower, if you're below the lower flammability limit, or some people call it the lower explosive limit, there's not enough fuel for this to actually fight. The flammability range is actually between the upper and lower. And if you are above the upper flammability limit, you don't have enough oxygen to be able to sustain a fire. There's so much fuel that you are actually, it's starved of oxygen and it can't continue. The scary part is when you are in fact working between the upper and lower flammability limits. That is when a fire can happen. We also want to talk about the internal responsibility system. Of course, employers have a duty to provide safe work practices, equipment, competent supervision. Supervisors have a duty to ensure that workers are working in a healthy and safe way, so they have to be competent. They also need to acquaint workers with all of the work practices, and they have to ensure that workers are using any protective devices required, and workers have to follow all of this. They have to follow the policies, follow the work practices, including things like storage, including things like disposal. So let's take a look at what the legislation says about flammable liquids. According to the OHSA and the Industrial Establishment Regulation 851, there are training requirements. Section 25, subsection 2, clause D talks about acquainting a worker. This is an employer duty. The employer shall acquaint a worker or a person in authority over a worker with any hazard in the work and in the handling, use, storage, disposal, and transport of any article, device, equipment, biological, or chemical or physical agent. These are, of course, falling into the chemical agent category. So this is a very wide-ranging provision of the employer duties that is also further explained in Section 130 of the Industrial Establishment Regulation that requires where a worker may be exposed to a biological, chemical, or physical agent that may endanger the worker's safety. They have to be trained on the precautions and procedures to be followed in handling, use, and storage of the agent. You'll notice that the previous one also talked about disposal. The proper use and care of personal protective equipment, and the proper use of emergency measures and procedures. And when folks say to me, well, you know what, like we don't have to train all of our staff on spills. If they're working with the product or they're working near the product and it could spill, yes, you do. Awesome. Thanks, Jessica. Yeah, as soon as you take the fire out, yeah, you can totally have that. All right, so let's talk a little bit about pre-start health and safety reviews, also found in Section 7 of Regulation 851. There's a table in there that talks about 8 different items, and we're going to talk about 2 that are relevant to flammable and combustible liquids. The first is table item 1. There is also, and Mike dropped it in the chat, the pre-start health and safety reviews guideline that comes from the MLI-TSD. So don't hesitate to look in that guideline for more information about all of the table items. In table item 1, this applies where either of the following applies with respect to flammable liquids. More than 235 liters of flammable liquids are located in a building or room, or flammable liquids are dispensed in a building, room, or area. And this is an or, not an and. So when we look at the dispensing, storing is one thing. Dispensing actually has an elevated risk because you are now moving it from one container to another. There's static, there's all kinds of things that can happen with dispensing. There are some exceptions though, because all of the following requirements have to be met for the exception to apply. No more than 235 liters of flammable liquids are stored per adequate cabinet. We'll talk about cabinets. We have 3 or fewer cabinets containing flammable liquids are in a group of cabinets, and the minimum distance of 30 meters between groups of cabinets. So if you've got a group of 3 cabinets and then 30 meters and a group of 3 cabinets and then another 30 meters, which is not quite 100 feet, give or take, that is, yes, absolutely. That is a great tip. If you've downloaded that, don't download it. I Google it every single time I need it to make sure that I'm getting the most up-to-date copy, always. So where we have, if you meet these requirements in table item 1 and you do not meet all 3 of the requirements of the exceptions, you in fact do need to have a pre-start health and safety review conducted by a professional engineer in the province of Ontario who is, the requirement is different from the fire code. Yes. Would using hand sanitizers in the office shop qualify under dispensing? That's a good question. When we look at the risks of that, I would like to get back to you on that. I would say probably not. I don't think everyone who is, also don't forget, this only applies to factories. So if you're working in an office, that's not a factory. If you're working in like a little retail store, that's not a factory. Section 7 only applies to factories. So if your workplace meets the definition of a factory as defined in Section 1 of the OHSA, then you start asking questions about whether or not Section 7, any of the table items apply to you. So I think that probably answers your question. Like if you've got a little pump of hand sanitizer at the front of your restaurant, you're good. You don't need pre-start on that. Because that's not part of the factory. Yes, you're welcome. So let's talk a little bit about would it apply to a lab that's within a factory? I would say yes, because you're within a factory. You could also make the argument that the lab itself may meet the definition of factory, which is quite extensive. It's very specific, but I would go and read the definition. Yeah, smaller quantities being dispensed likely don't need a PSR. Largely, they're focusing on a high risk, and hand sanitizer is not considered to be like lots of people have it. See, I think I even have a bottle of it sitting on my desk somewhere. And we don't need a pre-start health and safety review for that. Let's talk a little bit more about table item 4 now. Table item 4 is where you have a process with risk of ignition or explosion. And one exception to this is spray booths. So the exception is if the process is conducted inside a spray booth that is manufactured and installed in accordance with applicable standards, including NFPA 33, and meets both the Ontario Building Code and the Fire Code, you're good. The spray booth is designed for this. That's the whole purpose of having a spray booth. If you have a process that has a risk of ignition or explosion and you're not doing this in a spray booth, this typically needs a pre-start health and safety review. Now, the items that are out of scope for table 4 items are dispensing. So if you're just dispensing, that falls under table item 1, or appliances, boilers, or pressure vessels, or propane equipment that is in fact reviewed by the TSSA, because they're not, then you're kind of double dipping into the world of requirements. Yep, definitely look at the definition of factory. We also can't forget that the Industrial Establishment Regulation has a couple of sections about flammable liquids and fire prevention and storage specifically. Where not required for immediate use, flammable liquids shall be in sealed containers. I see lots of flammable liquid storage cabinets filled with things that are not sealed. Located either outdoors, remote from any egress, in a building not used for any other purpose, or in a room separated from the rest of the building with partitions, having a fire rating, equipped with a drain, and having natural ventilation. Where not required for immediate use, flammable liquids in open containers or having a flash point below 22.8 Celsius and a boiling point below 37.8 shall comply with the requirements of Clause 1B, be stored in facilities having no potential source of ignition, and where located in a room, be located in a room equipped with explosive venting to the outdoors and a spark-resistant floor. So that's a little bit about, things like open containers, closed containers, storage, and flammable storage rooms. They also have information about storage cabinets and dispensing. Section 22, subsection 3 talks about a maximum of 235 liters of flammable liquids may be stored in sealed containers of not more than 23 liters each, or in a metal cabinet of double-walled construction with a 3-point door latch and a liquid-tight door sill raised at least 50 millimeters off the floor, which is not very high, but it is containment. And section 22, subsection 4 covers an area where flammable liquids are dispensed shall have mechanical ventilation from floor level to the outdoors at the rate of 18 cubic meters per cubic meter squared of floor area, and containers dispensing equipment bonded and grounded where flammable liquids are being dispensed. So if you're wondering where bonding and grounding comes from, both Fire Code and the Industrial Establishment Regulation reference it. We also have portable containers found in section 23. A portable container used for dispensing flammable liquid in a work area shall be made suitable to provide for the safety of all workers and have a spring-loaded cap and a flame arrestor. That's one of those little like doop, 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 doop. And those are in fact a requirement. So if you're dealing with those commercially available, cans that you drag home from Canadian Tire, you want to go and put that into an appropriate spring-loaded cap container with a flame arrestor. Fire Code also talks about flammable and combustible liquids. Part 4 covers things like safety plans, spills, ventilation, containers, storage tanks, bonding and grounding, piping, distilleries, and labs. If you are in a lab, and we did have someone who mentioned labs, you need to go and look in the labs portion of section 4 because it does have some specific stuff for you. And if you're in a distillery, hot tip, you can go take a look in the Fire Code under the distilleries portion. Part 5 talks about hazardous materials, processes, and operations with flammable liquids. So things like hot surface applications. Let's say you've got a hot bathtub and then you're like spraying flammable stuff on it. That's a high risk activity. Spray applications, special processes like undercoating, floor finishing, bowling alleys have their own particular sections, and dry cleaning and dyeing plants do too. There's also dip tanks and hot work. So take a look at both Part 4 and Part 5 of the Fire Code. Work with a health and safety professional or with a licensed engineer in the province of Ontario who is competent working in fire and very, very familiar with the Fire Code. The Fire Code itself also provides further references to other things like ASTM, like the American Society of Mechanical Engineers, like the American National Standards Institute, and CSA, and the Canadian General Standards Board, and Compressed Gases Association, and UL, and ULC, and the National Fire Protection Association, or NFPA, National Research Council of Canada, the National Fire Code of Canada is referenced in the Ontario Fire Code, Transport Canada, Natural Resources Canada, and Ontario Office for the Fire Marshal. This is one of the reasons why a pre-start health and safety review for some of these higher risk activities is so important, because the level of detail that you actually need to go into to get this right is very high. And your licensed engineer who is qualified and experienced in working in this area should know how to reference all of this. So can you elaborate on what is mechanical ventilation for storage cabinets? Your cabinets, well, we're going to talk about cabinets, but they don't actually need to be vented. The room's mechanical ventilation is typically some sort of a fan, intrinsically safe. So what do we do to actually control fire risk? Ultimately, we're trying to remove either the fuel, the oxygen, the ignition sources, the potential for a self-sustained chemical reaction, and then you get rid of the fire. One of the big problems is we are constantly surrounded by oxygen. A fire won't occur if any of these things are not present in sufficient amounts or concentrations, are interrupted, or are removed. So how do we control fires? We can start by eliminating fuel sources by using things like water-based or detergent-based degreasers. If that barrel had been washed out with dish detergent and water instead of a flammable solvent, Eric Layton would still be here today. Water-based and latex-based paints instead of using flammable or oil-based paints, or we could choose battery electric tools rather than fuel power tools, so now maybe we don't have to use gasoline anymore, which would be a much better choice. In the post-secondary setting, although we don't meet the factory definition, we try to encourage PSRs. I would encourage PSRs, industrial racking, flammable. Otherwise, we don't have a consistent way to assess. It's tricky. It is. And do I recommend getting an engineer involved? I will never tell you not to get an engineer involved. Getting the smartest people in the room involved in anything that's dangerous is always a smart idea. I don't care if it's machine guarding, fork trucks, violence. There are so many different hygiene. There's so many different areas, ergonomics. There's so many different areas of safety. Getting some smart people in the room is never a bad idea. What is one of the other things we can do? We could try to eliminate some of the oxidizers. Eliminating atmospheric oxygen is not generally possible in ordinary work environments because people need this to breathe, and if they don't breathe oxygen, they die really fast. So how can we in fact work in these no oxygen environments? You can do it in a glove box. I've certainly done that working in lab world. But we also have inert gas environments or inert gas flushing. That's another way if you're in a fume hood or in some sort of ventilated space that's then carrying that gas away so you're not losing the atmospheric oxygen that people need to breathe. You can do gas flushing as well, depending on the types of operations that you're doing. But this is not generally one of the top ways that we control fire. It's usually a last resort. One thing we certainly can do is eliminate some of our oxidizing chemicals that are going to make a fire worse. These include things like halogen gases, chlorine and hypochlorite, peroxides, especially organic peroxides, chlorates, perchlorates. You'll see the word chloride, chlorates, ox a lot here. Nitric acid also can make fires worse, ozone and permanganates. By eliminating some of our oxidizing agents, we're not only, never mix these with your flammables. Not only are you really reducing the likelihood that a fire will start, you are also reducing the potential intensity for a fire. If you take like flammable stuff and then you add hypochlorite, even just household bleach to it, it is going to be massively worse than it would have otherwise been. We could also try to eliminate ignition sources by choosing those intrinsically safe pieces of equipment and maybe limiting the amount of non-intrinsically safe pieces of equipment that we allow people to bring into the workplace. If you're working with flammable and combustible liquids, flammable especially, maybe you have a cell phone policy that says people have to leave these in their lockers so that they don't have that ignition source like just sitting on their body at all times. We also want to think about things like ventilation fans, spark-proof tools, motors, being sure that anything that you're getting, motors or prime movers, that they are intrinsically safe if you're working in an atmosphere that has potential for a fire. But some of the other hot ones are gas detectors. Those are available intrinsically safe. A lot of the hygiene testing equipment. I've done some noise testing and we had to get intrinsically safe dosimeters for the staff that we were doing that noise assessment. Flashlights, radios. We want to really think about everything. If I take a human body and just, picture like that kid in the book wearing just like a t-shirt and shorts, and then I start adding stuff to this person, how much of this stuff is actually has a battery or has some sort of potential to create flammability, ignition source risk? Ask that question. We could try substituting. One of the classics is substituting combustible products instead of flammable products. Flammable products produce enough vapor day to day to already have a fire. Combustible products, you're going to have to get those a little hotter to be able to produce enough vapor. So even just moving from flammable to combustible is a huge improvement in your risk of a fire. We could also choose different formats. Instead of spraying something, which involves taking air, mixing it with something that is now flammable, and turning it into a cloud of potential fire, you could choose products that are brush on or roll on, so you aren't mixing these with potentially even a flammable propellant. When I think about a spray can, there's the product that's inside of it, and then there's the propellant, and typically they're both flammable, which is just flammable on top of flammable. Flammable liquid storage cabinets in Ontario, they are mentioned in, of course, the in Section 22 and Section 23 of the Industrial Establishment Regulation, but they're also mentioned prominently, unsurprisingly, in the Fire Code. You will find this in Section 4.2.10.5 of the Fire Code. The cabinets that are required, they have to comply with either ULC ORDC 1275 or to ULI 1275. They have to be FM approved or by FM Global, or they have to be listed as meeting NFPA 30, which is Flammable and Combustible Liquids Code. Some of the hot tips around these flammable liquid storage cabinets, of the things that I see people doing wrong with them, one of them is locating it next to an exit. That's a terrible idea. Not only is it mentioned in the Fire Code that you're not supposed to do that, and I believe it's also mentioned, it may have been mentioned in the industrial establishments, but if you are walking briskly away from a fire, You do not want to be walking briskly by all of your flammable products. So if I'm locating these in a building or room, I figure out where the doors are and I put them away from the doors so that as I'm walking to my exits, I'm walking away from my cabinets. We also want to ensure that every single container inside them is closed. I am, by the way, hyper aware in this photo that these are not, in fact, in self-closing cans with an arrestor cap, which would be a much better choice. This is a photo from Getty, and Getty doesn't always get the safety of their photos right. So I wanted to quickly mention that, because if this is what your cabinet looks like, you need to be mindful of that. Is there a limit on the number of flammable cabinets in a building or room? I would go take a look in the fire code for more information about that. They do talk about, of course, in the regulations in industrial establishments, they do talk about distances. And there is quite a lot of information about flammable liquids. There is section 4.2.10.2 that talks about maximum quantity per cabinet, and there is, in fact, a maximum quantity of fire per fire compartment. And you'll find that in 4.2.10.3. It specifies that for each single fire compartment shall not exceed the quantity permitted in Article 4.2.10.2 for 3 cabinets. For industrial occupancies of flammable liquids and combustible liquids, greater than those specified in one of the previous sentences, are permitted in a single fire compartment where the total quantity stored in a group of cabinets is not more than the quantity permitted for the 3 cabinets. And the distance between the groups of cabinets described in Clause A is not less than 30 meters. It's different for care occupancies, and then they go on to talk a little bit more about the cabinet. So I would really encourage you, Edmund, to go take a look. And the fire code is available on ELAWs in Ontario, but I would encourage you to take a look at the entirety of section 4.2.10. Other things to know about these cabinets. You're welcome. Other things to know about the cabinets. Noting the distance requirements. Note the capacity of the cabinets, never exceed the capacity. Also, put your smaller containers on the top and your lower containers on the bottom. If a shelf fails, the smaller containers are a lot less likely to break. If you put the small containers on the bottom and the big containers on the top, I mean, physics is what it is. Another hot tip is the containers, of course, have to be closed. And pay attention to your shelf clips. These things corrode like nobody's business. So I would include these on every single workplace inspection you do. Don't just look at the cabinet, open the cabinet and look at the shelf clips. I don't know what the heck they make them out of, but they just seem to like corrode like like leaving an untreated piece of metal in your backyard over the winter. I don't know why. I mean, I kind of do. Many of the products that are stored in them are also corrosive products. So like low-key, yes, I do know, but it always shocks me. And work with the maker of the cabinet to have some spare shelf clips kicking around in your workplace. Have like a little bag of them. We had a fume hood fire on campus where the armor cable corroded and started $1 million fire. Yep, corrosion is a huge issue. We think about these things as like set it and forget it, like a Ron Popeil like rotisserie chicken thing. They are not. They are a piece of equipment that needs to be inspected, maintained, and your cabling also applies to that. Same with your fume hoods. We'll talk a little bit about those in a second. All right, my last tip with flammable liquid storage cabinets is buy one that's fit for a purpose. They have all kinds of different styles. They have ones that are designed for drums. They have ones that are designed for, like for little bottles. Like you can get one that's like the size of like a vacuum cleaner or like 2 vacuum cleaners if you're dealing with a small amount. So think about all of the variety of things that you do. They have ones with little like spray can like holes. Get a cabinet that meets your needs and meets the requirements. As we think about containment, we can't forget about bottles and containers. Metal safety cans that are unbreakable, they're also bondable because they're metal, and the self-arresting, the flame arrestor and the self-closing cap, chef's kits. Those are the safest options you've got. And I really would encourage you to get them in metal, not plastic, because of the bondability. They are, though, not appropriate for high purity solvents. For those of us that come from lab world, high purity, you ultimately have to handle in glass. It's also class 1 and class 2 liquids. There are limits to container sizes. I just want to mention that for both. And glass, though, cannot be grounded or bonded, and it is breakable. So that's part of the reason why they have sizing limits. It is great for high purity, but the containers are really small. We're talking 3.8 liters for a class 1. Plastic is also frequently used. It also isn't bondable. It can actually melt, especially in a fire situation, and it can also be dissolved by whatever you're using. Solvents, you need to make sure things are compatible, otherwise your container will disappear on you. And they also have limited container sizes for class 1 and class 2 liquids because, again, this is a non-conductive container. I have a question about oil-based paints. Can they be stored in a flammable extract cabinet with gasoline, and would it be better to have them separate? So here's how I see the world of flammable liquid storage. The cabinets, do you need a separate combustible liquids? I would say no. If you have one cabinet and you have both flammable and combustible liquids, they're not chemical cabinets. Don't put the other chemicals in there. I've seen people put bleach, like it's a cabinet for everything. It's not. Flammable, I would be okay putting a combustible liquid in a flammable liquid storage cabinet. I would not be okay putting a flammable liquid in a combustible storage cabinet. If the label says combustible liquids, that indicates a certain level of risk. It would be okay to put a lower risk product in a higher labeled cabinet, but not the other way around. Let's go ahead now talking about bonding and grounding. So bonding and grounding is where you're equalizing electrical potential by connecting two containers to each other and the containers together. And then grounding is connecting that system to the earth. We've got an example of bonding and grounding with some really basic visuals there. And one thing to remember is that this is about container to container, not necessarily dissipating all of the internal static within a liquid. So again, nonpolar liquids, non-conductive liquids still have that risk of internal static, but this is a critical tool to be able to minimize the risk of a spontaneous static sparked fire. And in the case of Chankel's, this also, if that had been bonded and grounded, he may still be with us today. There are, by the way, special cables for this. There's a process that you need to follow. You need to be sure that whatever you are in fact grounding to is properly grounded to earth. So again, why do we have this need for a pre-start health and safety review? Because if you're doing things like dispensing, these are one of the things that the engineers actually look at. Are you bonding and grounding? What's the engineering of the system that you're using to do this to make sure that that system is in fact right? There's also ventilation and other types of engineering controls. If you are using ventilation, they need to be intrinsically safe fan motors. We want to be sure that we've got that draw for, again, top and bottom. And fire curtains and fire compartments are another good example of our engineering controls to prevent spread of fire. Spray booths can prevent spread of fire. Oily waste rag containers, you do have to empty those every single night, just like the label says, is intended to contain a fire. And remember, if you've got like an oil-soaked rag, that can actually self-heat just from the product evaporating off of the rag. And that's sometimes how those fires start. How do you pour ethanol from a 4-liter plastic jug into a metal container safely if you can't ground plastic? So one of the good news pieces is that ethanol is quite polar, and it does, in fact, conduct electricity relatively well. So what I would do is I would actually use a funnel or a grounding rod that allows you to ground to the inside of the container and to the liquid itself, and then just pour along the rod or have the rod inside of the funnel, have it touching the funnel, and you've got this continuous electrical pathway. This is why metal funnels are still the cool stuff for doing this. You could also be using pump dispensers that have flame arresters. Even if you're soaking a rag, they have like a little like doop, 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 soaks the rag, got a flame arrestor, really, really easy to use. And you could be using a bonded pump for a drum. So if you're having to actually pump from a drum where you've actually got bonding to the receiving vessel, the actual drum is bonded and grounded, and then the actual pump itself has grounding to it as well. So much better choice. That would have been a safer choice and probably saved a life. Knowledge is power. We need to train our staff and we need to double down. What do they need to know? Handling, storage, use, disposal. They need the hands-on of actually how to do this in your own workplace, in your own context, with your own products, with your own controls. But they also need to know how to respond in an emergency, both in a spill situation and in a fire. They need to know how to use a fire extinguisher, which is not an online course. I would really encourage you to go and do a hands-on, like there's one where they set up a little fire with like a propane thing, and they actually have to practice. That is the kind of training that I would recommend. Every single person in your workplace, if you're working with these, needs to know how to use a fire extinguisher properly. And you also need to train them on what are the higher risk things that can create fires. What are your ignition sources? How are they being managed? How are you managing your fuel in a way that reduces risk? Ultimately, staff have a right to know what's dangerous and exactly how you're keeping them safe, and you need to marry those two things together. Yep, most fire departments do have it available. Spend the money. You will not regret it. So flavors of low flame point. We currently have it in a cooler. If you're keeping anything in a refrigerator, by the way, it also needs to be intrinsically safe if it is flammable, because they also have potential for sparks. And don't store your lunch in your chemical fridge. Safe work practices do have written procedures for things like decanting and transferring, storage, including how you're storing any incompatibles. We need to make sure that we're storing all of these various things appropriately and very far away from each other. Spills protocol do have appropriate adsorbents. Not all adsorbents are appropriate for flammable liquids, so you need to have the right spills kit, spark-proof shovels, so that as you're like sweeping things up, you're not creating new spark problems, and staff do need to be trained. And don't forget that this loaded adsorbent is also now potentially flammable, so that needs to be disposed of as hazardous waste. Someone did mention challenges with disposing of hazardous waste. Work with your local hazardous waste disposal company. That is what they are paid for. Is it expensive? Yes. Is it worth every penny? Also, yes. You could also establish batch or quantity limits. That's again more of a policy process type issue. For folks that are working with pyrophoric products, like often they're using like 1 gram, 5 grams, and that's it. That's all you're allowed to use. If you go beyond that, the risk goes up really, really fast. This is also true for flammable liquids. So if you're using really small amounts, the likelihood of a really big fire is much smaller. Smaller amounts, smaller fires, lower risk. We can't forget about our clothing and personal protective equipment, because when we look at one of the more recent fire deaths in a lab context, it was Sherry Sanji, who died at the University of California, Berkeley. She was working with a pyrophoric substance. She was not wearing a lab coat. That really wasn't enforced where she was working. She was a freshly graduated undergrad student, so really, really new to lab work. And she was wearing a polyester sweater. There was a fire that occurred at the fume hood, and it caught her clothing on fire, and she subsequently died from her burns. You need, if you are working with flammable and combustible liquids, to think about what people are wearing and rigorously enforce this. They should be wearing Nomex or flame-proof uniforms. So be sure that you are getting appropriate fire-resistant clothing. If you're choosing footwear, leather pull-on static dissipating footwear. Why leather? Why not just sometimes have little metal grommets? I also happen to prefer, and you can use a lot of different styles. I also really like Blundstone work boots for handling chemicals, because the whole top is covered. You don't have a tongue where things can actually like pour down onto the foot. It kind of pours off. That happens to be my preferred choice of boot, simply for that reason. We also have clothing policies. I would encourage your staff, and be sure they understand why they need to wear 100% cotton or wool garments even underneath their coveralls, because this stuff, if it burns, wool doesn't burn, but also if it's cotton and it catches on fire, it ashes and falls off the body. If you're wearing polyester, synthetic, fleece, do not allow this. It will actually melt to the skin, and that ultimately could lead to a fatality. where a fatality may not have occurred if they were choosing different clothing. As we're tailing off our session today, FR clothing for the win. What about wearing Tyvek suits over clothes? Those sound super flammable. I would not be wearing that. They're made of plastic, ultimately. I would ultimately be looking at the risk. We also want to consider what the risks are of the chemicals. We need to be sure that we're providing chemically resistant clothing, but there are options that are both flame resistant as well as will provide adequate protection. So it's a great example of having to consider a number of different factors in our personal protective equipment decisions. If they are a flame retardant Tyvek suit, you have the flame retardant. Then we're good. They've actually impregnated chemicals into them to make that work. We do not wear synthetic clothing, especially underwear. It will melt. Yes, it will. Fire preparedness and response. There are certain circumstances where you're actually required to have a fire safety plan under section 4.1.5.6 of the fire code. This is where it applies where in buildings and open areas where the quantities of flammable liquids and combustible liquids exceeds 500 liters in total or exceeds 250 liters of class 1 liquids. We need to be prepared, and preparedness comes with things like fire detection systems or sprinkler foam and gas-based fire suppression systems. Fire blankets are also a great choice. I like to have both an extinguisher and a fire blanket, both at home and in workplaces, because fire blankets are a lot more idiot-proof than a fire extinguisher. You take the blanket, you put it on a fire, you kind of squish it around, and it actually is designed to cut off the oxygen. I have one at the cottage because my family are not smart people, and I don't think any of them know how to use a fire extinguisher properly. But I put a fire blanket there next to the fire extinguisher in the hopes that if there is a fire, and there has been, that this will be something that someone will go and grab. We also want to think about our emergency evacuation point, our plan, our muster point, and check-in procedures to be sure that every single person got out of the building safely. So if there are firefighters that are arriving and you're like, nope, everyone is accounted for, that they're not going in and looking for additional people. They can focus on fighting the fire. And do have a way, and we talked about it earlier, of being sure that you can communicate information about the products you have to your emergency responders so they are prepared. So as we are wrapping up, how can WSPS help? We have a fantastic MLITSD Hygiene campaign toolkit that our fantastic safety connection team will send to you. It includes things like an FAQ, how to read a safety data sheet, and a compliance checklist for both 860 and Regulation 833. We also have a chemical management program building block along with chemical inventory assessments. We have coming new to you a WHMIS training on site specific. This is a half-day workshop that tells you how to go and develop. This is free to attend. How to actually go and develop your site specific training for your chemicals. And we have some additional great resources on our website. We have complimentary consulting, including doing compliance assessments. We can come right to your workplace or do them over the phone. And you can come and take some courses. We also have the Excellence Program, which if you have not already had a chance to enroll in the Excellence Program, it is like your 10th grade math teacher giving you $20 every time you do your homework. Yes, you have to do the homework to get the money. That is not a surprise, but it is hands down the program that is probably the least understood. And I don't understand why every single workplace in the province is not registered for this. You build topics, it's based on your needs, where you're at in your safety program, and it is a way for you to be able to create safety as a self-sustaining little cycle. You build some cool safety stuff, build new programs, get money, allows you to build more cool programs, get money, build cool programs, workers go home safe, everybody is happy, WSIB claims go down, fire risks go down, et cetera, et cetera, et cetera. It's like a perpetual motion machine of health and safety, and you can get a lot more money than you think. All businesses, your rebates are doubled. You can even get more money than you paid in your WSIB premiums. Some people are using this as a money-making adventure. So that is a little bit about the Excellence Program.